2 to 3 more weeks, guys. You're almost at the finish line, so just keep pushing, all right? I heard that the lab exam was a little bit hard today, but please don't let that stop your, momentum. Let's just keep pushing. So, in this video, I'll be covering code coverage. This is the problem from the formative assessment. But before we start, I do want to point out some key things. As you can see, we are not going to be using any asserts, try, or excepts. This is a little bit different. All we're doing is that we're not actually making a program, but we're actually testing someone else's code. So you notice that we didn't make this code in the formative assessment. We're testing someone else's code, and we need to make sure that all of the lines run. And that's what full code coverage means. All of the lines has to be fully ran / fully covered. Down here, I kind of wrote the state of a line. A line could either be covered, kind of covered, or not covered at all. So what not covered at all means is that the line of code never ran. Covered means it got fully executed. Kind of covered is a little bit trickier. Sometimes people call this partial coverage, but it's when you have an if statement, like if the value is equal to 6 and you only cover when it's false. Because you only covered when it's false, you need another test case where it's true to have that full coverage. And I'll show you what I mean as I get to the video. Alright, so to begin, let's first observe this line of code and figure out what it does. So as you can see, we have two assert statements right here, which I kind of want to fail and pass to make sure we get full test coverage. So we have a statement that makes sure that it's a list. Then we iterate through the list and make sure everything inside of that list is an integer. Next, we get sum, initialize it. We initialize a flag. We loop through the list. If it's 6, set the flag equal to true. Else, if it's 7, set it to false. If it's not flag 67, basically if flag 67 is false and the value is not 7, the current element is not 7, then you add it to the sum, and once you're done looping through the list, return that sum. Alright, so first let's fail this test case and later we'll pass it. Because if you think about it, if we give a valid input, it'll cover a lot of this stuff, but only partially cover these guys. So to get full test coverage, we need to make sure we fail these assert statements first. And to do that, I'll show you this example. Sum 67, and we do not pass in a list, but instead we pass in the string hi. So what happens here? Let's walk it through. It covers, line 1 because it's just a function. So, okay, cool. Assert type numList is equal to the list. Now, because we passed in a string, this assert statement is going to fail. So this covers lines 2. I don't know if you're supposed to include 1 or not, to be honest. Just check the formative assessments. But this kind of gets ran no matter what, so it doesn't really matter. So this, it partially covers assert equals type, numList equals the list, because we only have one scenario. We failed it. The next scenario we have to cover is when we pass it. So we can kill 2 birds with 1 stone. Let's give it a list, but give it a list of strings. So we do sum 67. We actually give it a list, but once again, we give the string hi. So let's see what happens now. It runs line number 1, so that's good. Number 2, it passes this one now. So this guy I would consider fully covered. And yeah, check mark is equal fully covered. And next, for every value in the num list, we are going to do that. So that's fully covered. Assert type v is equal to an integer. Because we have a string, this is only partially covered. So let's mark this as partially covered. And real quick before we continue, guys, I do want to emphasize that I know the formative assessments are digital, but if this is a problem that you get pen and paper, it's actually a good idea to draw on it because you get to keep track what lines are fully covered. For example, we have fully covered lines 1, 2, and 3. What lines you have partially covered, which is 4, and you get to keep track of what lines you need to cover, which is all of these guys still. So because we failed that, this guy's only partially covered. So let's say this guy passes through 2, 3, and kind of 4. So we'll actually give it a valid input now to pass through even more test cases. Our next input is going to be sum 67 bracket integer 5. Now, disclaimer, there is a better test case than this to cover more lines. I'm just doing this just to show you like a point about the if statements I was talking about earlier. You'll see what I mean when I do this. So whenever I pass in the list with only one element, which is 5, it runs line number 1 fine, line number 2, line number 3, line number 4 will now be fully covered because we actually passed it instead of just failing it. Next, it's going to run lines 5, so this guy's covered now, line 6. The reason why these are fully covered is because it's doing something simple. It's just initializing it. There's no other way it could go, like true or false. It just does its job. Next, for every element in the num list, this would for sure get run. This guy though, if the value is equal to 6, we don't have that. We only have 5 in there. So this partially covered because we covered whenever it's false. This guy does not get ran at all, so we don't mark it because it's inside the if statement. So we never actually ran this piece of code. We skip to this guy and check if the element is 7. 5 is not equal to 7. So this guy is partially covered because we only covered the false branch of it. This guy is not ran where you set flag 67 equals false. It is not ran because it is in the elif statement. Next, if not flag 67, that basically means if it's false, which is true, and the value is not 7, that's true as well, we have 5, then this guy is also partially covered because we ran it whenever it's true. I guess it's a good idea to keep track of what we have so far. So this is the stuff we have. So we got it when it's false, we got this guy when it's false, we got this guy when it's true. So because this is true, sum plus equals value, this is not a conditional statement, it just adds something together. So this will be considered fully ran. Once we're done with this, is there any more elements in the list? No, we just have 5. So we return it, and this is good. I don't know why I put true there, guys. Sorry, it's supposed to be a check mark. All right, cool. So what do we have, guys? So we have fully covered lines 1, 2, 3, 4, 5, 6, 7, 13, and 14. And we have some partially covered stuff and some that didn't even run at all. So we need to star the ones that we didn't run at all. And we need to fully cover the ones that we partially covered. So I guess before I forget, let's say what lines this guy did. He did 2, 3, 4, 5, 6, 7. Kind of did 8. We'll include it anyways. Did not do 9. Kind of did 10. Did not do 11. Did 12. Kind of, like it's partially, you know. And then fully did 13. Okay. Alright, cool. So now that we have that, now we need a test case to cover the rest of the lines, which is lines 8, 9, 10, 11, and kind of 12. Alright, cool. So to do that, let's do sum 67, 1, 2, 6, and 7. Close the list, and let's see what happens now. These few lines are going to get covered, so def is going to get covered. Lines 2, 3, 4, 5, 6, and 7. They're going to get fully covered, just like in the example here. So let's see if v equals 6 get ran at all. So 1 is not going to hit it, 2 is not going to hit it, but 6 is actually going to trigger this conditional statement and is going to make it true. Because we finally made it true, this guy is now fully covered. So let's do a double check mark right here. Good job. All right. Next, because it's the value right now is 6, finally this line of code will be ran. So let's do a check mark here. All right. Is 6, well, this line of code, elif v equals 7, because we hit this conditional statement and this is an elif, we're actually going to skip this guy. Next, we're going to run this line of code because there's double if right here. So this if statement will run no matter what. If not flag 67, is it not flag 67? No, because we set it to true. So this guy's not going to run. So now we have fully covered this guy because we have covered a scenario where this is false. So let's make this guy as fully covered. Sum, we're not going to run that because it's 6. And we're not going to return because we have more elements in the list. So next up, our next element is going to be 7. And let's see what happens. For this, if the value is equal to 6, which is not, we're going to skip to this guy. Elif the value is equal to 7. Because that is true, we are at 7. This guy is now true as well. This guy's fully covered. Because remember, we covered true and false branch. Because we finally hit 7, flag 67 is going to be set to false. This line of code actually runs. And now we're going to run this guy, which is going to be false. Because, the value is 7. This wants it to be not 7. And because that's the end of our list, we're going to return it. And as you can see, that test case is done. So let's take a step back and see what lines have we covered. we have covered 1 successfully, we have covered 2 successfully, we have covered 3, 4, 5, 6, 7, 8, 9, because, make sure that we don't only partially cover stuff. 10, 11, 12, 13, 14. So this area right here is just to make sure that we got everything. Double check your work, guys. Sometimes when you draw too much, it gets a little bit messy. You see how all the check marks that I have here in the true and false? This is just to, run it in our head. But this guy is able to cover a lot of lines, so I'm pretty sure this covers lines. Honestly, it probably hits all of them. Like, you can just 2 to 14. So yeah, just list out 2 to 14. Double check that. I'm pretty sure it runs all of the code. And yeah, that is code coverage. So just to recap what we did here, we're not using any assert statements. We're not using try or except. All we're doing is calling the function multiple times to make sure all of these lines ran. And you saw my test cases. I wanted to make sure that they're all covered, and there's 3 states to lines: covered, kind of covered, and not covered at all. Multiple test cases, these were able to partially cover some. We need more to fully cover it. And honestly, that's it, guys. So yeah, if you have any questions, I guess make a quick ed post because it's kind of late. And yeah, good luck on your exam, guys. Hang in there, all right? We're almost done. We're in this together.